I have been asked to redo examples 7 and 8 from notes on 1-6. So I am going to do that right now. So just so you know, this is called a binomial that has a radical. So if it could be in the numerator, could be in the denominator. Whenever you have a binomial that is a radical, what you're going to do is multiply by the conjugate of that binomial with a radical, because when you plug 0 in the top for the x, you get out 0 in the numerator. When you plug 0 in the bottom, you get out 0 in the bottom. So we're going to multiply the top and the bottom by the conjugate of that radical part. You're going to multiply by 1, so you got to do the numerator and denominator by the same thing. So that top part is called a conjugate, and when you multiply a conjugate, you get back the difference of two squares. So when you FOIL that top part, when you take radical x plus 1 times and square that, because it's a difference of squares, you get radical x plus 1. And because it's a difference of squares, you need a minus. And then you got to square the 1 up here. When you square 1, you get 1. And on the bottom, do not multiply them. Just write them as multiplied together, because the whole goal here is to get rid of the x in the denominator so you don't have a 0. So when I add the 1's together on the top, those cancel out. And I get an x on the top, and I get an x times the same denominator. And then those x's reduce. So that reduces, so I'm left with a 1 on top. So then I'm going to stick a 1 in, or 0 in for this x in the denominator, which will give me radical x plus 1, or sorry, radical 1 plus 1. And the square root of 1 is 1. So this whole thing is 1/2. That would be the limit on this problem. When you look at problem number 8, this problem is a complex fraction. Now I make everything into fractions on this, and then I look at my x plus 3 as a denominator, my 3 is a denominator, and the 1's a denominator. So you want to find the least common denominator of these three things, which is the least common multiple of these three things. So 1 times 3 times x plus 3 makes the least common denominator. 1 times 3 is 3, and then times that quantity. So you're going to multiply the bottom by that same thing, which is 3 times x plus 3. That's your common denominator. And you're going to multiply the top by that same 3 times x plus 3. And you're going to end up distributing that to both of these numerator parts. So I'm going to go ahead and say I'm distributing it over here and write it over here with this one as well. And what this is going to do is it's going to get rid of my complex fraction, because this x plus 3 reduces with that x plus 3. And this 3 times 1 is going to give me, that 3 times 1 is going to give me a 3 here. Now I got this minus sign, and these 3's are going to reduce. So I have a 1 down here now, so I don't have to have a denominator. And I got that minus sign. So now I got minus this x plus 3 deal here. Now you got to leave that x plus 3 in parentheses, because you're going to distribute this negative sign to both of those. Then on the bottom, the x times the 3 is 3x, and I have x plus 3 still. Now remember, my whole goal is to get rid of that x down there, this x that's here. Now on the top, I'm going to distribute my negative sign. That's going to give me 3 minus x minus 3. And you leave your bottom the same. Don't FOIL it in there, because we're trying to get rid of that x. If you do, you have to factor it back out. Now this 3 and this negative 3 cancel out. They actually reduce to 1. They don't really cancel. So now I can reduce this x and this x. I'm sorry, this 3 and negative 3 do cancel. These reduce to 1. So that leaves me with a limit as x approaches 0 of negative 1 over 3 times the quantity x plus 3. So that got rid of that x in the bottom, so that now I can plug the 0 in to the x. And 0 plus 3 is 3, and 3 times 3 is 9, so that would be the limit on number 8. I hope this helps.